students, now let us once again continue with one more problem on BLT, that is bilinear transformation. Find the bilinear transformation which maps the points 0, minus I, 2i into w is equal to 5i infinity and minus I by 3 respectively, and also work for the invariant points. Let's solve this problem same as the previous one, but here why I have brought this particular problem is you have infinity in the place of w. Okay, how will you substitute w as infinity? Previously in my previous problem we learnt when z is appearing, when z is having a value of infinity, then how to work for that type of problem I have already discussed before. Now let us continue the discussion. When you have w as infinity, then how will you solve? W is equal to 0 or z is equal to 0, you don't have any problem to worry. Okay, only problem comes when you have infinity. You have to little vary your standard bilinear transformation and consider it. Okay, let's see how to do it here. So here we are having, let us first consider the standard form. You have w is equal to a plus az plus b divided by cz plus d as the given BLT. Okay, now first point we'll take, if z is equal to 0, you are having w is equal to 5i. 5i is equal to z0, substitute z as 0 here, it will be 0 plus b divided by 0 plus c, 0 plus d. Okay, or this will be b divided by d, or I can write here, this implies b divided by d is equal to 5i, or if you further write it, it will be b minus 5i into d is equal to 0. Call this as equation 1. Okay, you are done with first equation. Similarly, if z is equal to minus I, you are given with w is equal to infinity. Here you have to worry about. Okay, so to work for w is equal to infinity, you are not going to put infinity directly here. Instead you will consider what is 1 by w. 1 by w is what? Cz plus d divided by az plus b. Okay, 1 by, if w is equal to this, 1 by w will be this. So that if you put w as infinity here, 1 divided by infinity turns 0. So this part turns 0. So it becomes easy for you to solve this problem. Okay. Otherwise, if it is turning as infinity, you won't be able to solve it. So to avoid infinity, better to take the reciprocal of w, which is 1 by w, which will be cz plus d divided by az plus b. Quite exact reciprocal of this. So now if you put z is equal to minus I, it will be 1 by infinity. 1 by infinity means it is 0 is equal to, you are putting z as minus I, so it is minus c into I plus d divided by minus a into I plus b. Okay, and if you just simplify it further, you will get this multiplied over here, 0 into this bracket turns 0. You will have minus ci plus d is equal to 0 as another equation. Call this as equation 2, call this as equation 1. Okay, yes. Now let us continue. If z is equal to 2i, you are having w is equal to minus I by 3. I by 3, it is 2ai plus b divided by 2ci is equal plus d. You will get it something like this. Now further simplify it. Take it to the left hand side. So you have, I'll write it here. Okay, so 2ci minus 2ci I into I square minus I into d is equal to 3 into this, it will be 6ai plus 3b. Okay, so let us rewrite that equation. I square is minus 1, minus 1 into minus 2c, it becomes plus 2c minus id is equals to 6ai plus 3b. Or if you rearrange everything in alphabetic order, you will have 6ai plus 3b minus 2c, here it is minus, get it over here, it becomes plus id is equal to 0. So you call this as equation 3. So for 3, equation 1 can be written as b plus solving equation 1 and 2 I will say first. Okay, so b can be written as, equation 1 can be written as b plus 0 into c minus 5 into d is equal to 0. Similarly, equation 2 can be written as 0 into b plus, okay, there is a minus sign, minus I into c plus d is equal to 0. So these are 3 unknowns and 2 equations. Once again we work for the proportional values of b, c, d. Okay, b divided by the determinant, by the c divided by the determinant, d divided by again a determinant. So I hope you all know how to work by now. This is the third problem we are working like this, minus I and 1. Here the coefficients for 1, minus 5i, 1 minute, minus 5i and 0 and 1. Okay, next it's 1, 0, 0 minus I. Okay, so this is what you get. Yes, and that should be equated to some constant k. Okay, now simplify this. 0 minus into minus plus, but lower limit, I mean 0 into 1 minus this into this minus this into this. So it will be minus, okay, 0 minus I into I square, minus of minus plus 5i square you get. Okay, is equal to minus c divided by 1 minus 0 is equal to d divided by minus I minus 0 is equal to k. Or b divided by I square is minus 1, there is a minus sign here as well. So it will be 5 is equal to minus c divided by 1 is equal to d divided by minus I into k is equals to k. Okay, so let's work for the first equation. B equals 5k you get, equated to the last constant. C equals or minus c equals k, or c equals minus k you get. Okay, next, 1 minute. Okay, and d is equals to minus ik, the last. Now we have got one equation, that is equation 3, which is connecting all the variables. From this equation we can work for the value of a. Let's work for that. 6ai, value for b we have got 5k, so it will be plus 15k. Look at this, plus 15k. Okay, b we are substituting. C we have got it as minus k, so minus 2k. And look at this, it is minus 2c minus c value, so it becomes plus 2k here. And d we have got minus I into k, it is plus ik. Okay, plus minus into plus, it is minus, but I square gives you minus sign, so it becomes plus k is equals to 0. Just put that way. Substitute all the values in this equation. A we do not have, b we have got as 5k, 3 into 5 is 15k. Now minus 2 into c, c is minus k, so it will become plus 2k. Now d is minus ik. If you substitute it, it will be minus I square d, minus I square k. Minus I square is plus k. Okay, so you'll get plus k. So if you add all of these, 6ai is equals to minus 18k. Okay, a is equals to minus 18 divided by 6i into k, or it is minus 3k divided by I. 1 by I told you a number of times what is 1 by I. 1 by I is minus I itself. Okay, replace it by that, so we'll get minus 3i into minus I, or it is 3ik. The value for a is 3ik. This is a. You have got b, you have got c, you have got d. All the values you have got now ready. A, b, c, d. So let us substitute that in the transformation w. Okay, so w is 1 minute. So w is a value is 3ik into z, plus b is 5k, right? Divided by c is minus k, so minus k into z, plus d is I into minus ik, so it will be minus ik. Okay, so you can take k common from the numerator as well from the denominator. Okay, with the negative sign, so you'll get 3i into z plus 5 divided by z plus I. Okay, so we'll be getting this as 3iz plus k plus 5 with negative sign, because I am taking this minus sign to the numerator, z plus a. Okay, you will get it something like this. This is the required transformation, but I just want it in the standard form because this is not the standard form. We will reduce this to standard form by taking I common. Take I common from the numerator. Okay, if you take I common, in fact, take I common from the numerator, you will have 5 divided by I, minus sign over here, 5 divided by I plus 3z divided by I common again, 1 plus, 1 minute, okay. So you are having again, I told you to take I common, so it is z divided by I plus 1. Okay, I gets cancelled here, so again 1 by I is minus 1, 1 minus I. Okay, so replace it, so minus sign as it is, 5 into minus I plus 3z divided by minus z into I plus 1. You take this minus sign inside, 5 plus 5i minus 3z divided by 1 minus zi. I can write it like this. Okay, this is the required bilinear transformation. So you can stop it here also, that's not a problem, but it will be better if you this looks very, this minus sign is, we have to remove that. For that purpose you can take it inside and write both the numerator will be minus, but if you take I common, you can solve it the way I have done before. Okay, this completes the solution for this, but you have to even work for the invariant points. So let's work for the invariant points here. Okay, let's work for the invariant points. So for working for the invariant points, as I told you, you are going to put z is equal to w. Okay, let's put z is equal to w and work for the invariant points. Yes, we have got, we got w is equal to 5i minus 3z divided by 1 minus zi. Put w is equal to z here, you get z is equal to 5i minus 3z divided by I minus z into I. Take this to the left hand side, z minus z square I is equal to 5i minus 3z. Okay, and when you further simplify this, minus z square I plus 4z minus 5i is equal to 0 you will get. Okay, so divide by I throughout. Okay, so it will be minus z square plus 4z divided by I minus 5 is equal to 0 you will get. Again 1 by I, here in the middle term it's 1 by I, 1 by I is minus I, minus z square minus 4zi minus 5 is equal to 0, or that equation is z square plus 4zi plus 5 is equal to 0. Like this you get. Just see that what we are doing. Yes, look at this. Z square I, you have the just same equation. I'm just taking the left hand side and collecting all terms to one side. When you collect it, z square I, 3z minus 3z comes here, it becomes 4z. Okay, because it here plus z you have, again plus 5, here it comes minus 5i. I do not want I over here, so I am dividing throughout by I. So if I divide it by throughout by I, you get something like 0 divided by I is 0 only. Okay, but 1 by I is minus I, so you will have a minus 4zi same, every term is same here, but minus 4zi you will get, because 1 by I is minus I. So once you get that, you will get this equation. Then after that, work for z. So it is minus 4 plus or minus root of 16 minus 20 minus 4i you should get, and I square is 1 minute, yes, minus 4i divided by plus or minus root of b square, which will be 16i square. I square is minus 1, 16i square means minus 16 minus 20 divided by 2. You should be getting like this. Okay, so if you work for this, it will be z is equal to minus 4i plus or minus root of minus 36 divided by 2. Okay, so this is nothing but minus 4i plus or minus 6i minus root of minus 36 it is. So plus 6 plus or minus 6i I can take. Okay, so z is equals to minus 2i plus 3i, and another point minus 2i minus 3i. These are the two invariant points given. Okay, yes, and when you solve this, it will be z is equal to, if you simplify, it will be I and minus 5i. These are the two invariant points. Okay, just completes the solution for this problem. Okay, continue in my next session.